different perspectives. So we go very quickly through them. Relevance, are we tracking actually meaningful things? Richness, do we have enough context in all of these data? And coverage, things like ad blocker, browsing protection, tracking protection, are we actually tracking what we intended to track? Accuracy, tracking issues and that kind of stuff. Latency, usually not a problem, but how fast can we actually use the data? At least it's not a problem for analytics use cases. And finally, ease of consumption. This is oftentimes a problem, that it's very hard to understand the data which are actually collected, and we end up in a situation where just a few people can actually work with the data in a huge organization. Finally, traceability. Who is actually responsible for creating that individual data point, and where is it used, etc., lineage, that kind of stuff. But a fundamental aspect of data quality, or in other words, we shouldn't be obsessed with data quality. But on the other hand, data quality is a fundamental aspect of getting trust in data within an organization. Without trust, no one is actually using the data, and you will have no meaningful impact with data. So data quality is kind of the currency to getting trust in the organization, because if even the best models have no impact if data quality is not ideal. Surprisingly, all the tools we're using are providing not so much features to actually collect high quality data in the long run, which is kind of weird because we're all facing the same problems. There are differences between the tools, but in general, the majority of the tools which are highly adopted, let's say GA4, Pivik, maybe even Adobe, they all have minor features, but not like huge one that enables you really to like validate stuff. Of course, we cannot like cover the whole part of an implementation of a robust data pipeline. There are so many different aspects, alerting, assertions, monitoring, that kind of stuff. So today, we want to focus on a very crucial part, the actual implementation of events. Because this is by far the biggest issue when it comes to data quality. We are using Snowplow Analytics, but in general, these principles we are using can be applied to any tool. So don't lay back and think, that's not possible with my tool, or we don't get the resources and that kind of stuff. Data quality is so important even in the times of AI, when we're using AI, want to use AI, you basically cannot use it if data quality sucks. So, schemas are a fundamental part of Snowplow. So an event schema is basically a contract between developers, data creators, and data consumers, analytics engineers, business analysts, and so on. So a schema defines a data type, validation criteria, and a description for every single property which is part of the event. And schemas are never getting deleted. They are fully versioned. So it helps a lot in terms of traceability and responsibility. Who is creating that event, for what's the event trigger, and so on and so forth. Even if the tool you're using is not like fundamentally using schemas within the whole collection setup, like Snowplow, I think you can still using schemas to define event structures or define events. Maybe Maciek, you can show something like that. I'm very happy about it.
Later.
Yeah, that's great. That's great. Okay, so what we built. So we have these fundamental event schemas called JSON schemas here. We transform them automatically into TypeScript types and so-called helper functions that developers have like a safeguard how they actually implement this within the front end or within an app. And all these events are getting translated into fact tables. And we define the definition of the properties, so the description of the properties, we define them already in the schema. They appear in the type as well as a node, and they appear finally in the fact table, so in a column description that downstream consumers understand what the property actually means. And because this is very abstract and it's maybe hard to get, we right dive into, and Remo is showing you how this is actually look like. Maybe as a first starter here, it's a fully hard-coded implementation, no tag management system. That sounds scary for some of you, yeah, but there's a good reason for that. So tag management per se is not an issue. I mean, it's probably the best choice for a lot of organizations. But in our case, we had continuous deployment, so we deploy the online show multiple times per day, sometimes 10, 15 times per day. We have a hard focus on performance, so in the hardcore implementation gives you way more tools to actually optimize track in terms of site speed and performance than a tag management system. And it's good in terms of the data mesh principle, which is a core principle in the whole data sphere at Digitec Galaxus, so that the teams can actually have ownership of events they're producing. And that is kind of the issue when it comes to a tag management system. So we all know that tracking must be kind of a core of the feature and not just a sidecar. And a tag management system kind of supports this culture where developers see the data layer, which is very common in tag management system, is just a very abstract object where they push things into it, but they don't feel any ownership, and I can understand that, because they're not actually owning the event end to end. They're pushing into the data layer, the tag management system is consuming this data, another SDK is transforming the data, and this is finally the event payload. So I can kind of understand that developers sometimes have a hard time to get full ownership of events produced with a data layer and a tag management system. So this is, at least from my perspective, I'm very opinionated on that one, but I think this is kind of the issue why analytics is sometimes a sidecar of the whole application. So it's always threatened as something else, but it should be something fundamental. And in our case, so it was that we, as a product analytics team, we was like the owner of schemas. We maintained them in the UI. Developers had no way to actually work with them, change them, and so on. They just got them at some point, but this was not so great for developer experience because it drove the developer outside of his so-called inner loop. He was dependent on us. There was a lot of back and forth. The communication was spread around different tools, Jira, Teams, whatever, Confluence. And now developers can change schemas in Git, and the whole communication is centralized in one place. This increases traceability a lot because we can understand in the long run how a schema changed and why. And in the end, it's also building the foundation to have AI agents and that kind of stuff, which are validating these kind of schemas and maybe evolving the schemas and doing tests and so on and so forth. And now we're hitting already the time that Remo is showing some hands-on stuff, and I'm really excited about that. Maybe a quick applause for Remo. So
maybe I need to grab the microphone too?
Yeah, sure. Ich sehe es gerade gar nicht. So.
Yes.
Here.
Okay.
Okay, cool. Okay, hi everyone. I'm Remo, a front-end developer at the Digitec Galaxus, and I want to show you how we work now with schemas for snowplow. Yeah, as already mentioned, the schemas are all stored directly in our repository. So I can jump here to the GitHub UI, and we see here the entire repository. So this is also the repository, a so-called monorepo, where the shop application is hosted to or stored to. And here we are in a specific package of the whole application, which is dedicated to Snowplow. So here in this specific folder, we see all the existing schemas. So I can also jump into one. Maybe it's a little bit small. It's okay for... Okay, we don't have to read it in the entirety, but we can see basically the idea that we have the schema definition in this file, but we also have some metadata down here, like the version, which is crucial for the entire schema management. So now in this case, what I want to show is our flow, how we create a completely new schema. And for that, I can just go with the GitHub UI. Here top right, I just hit create new file. I'm already in the right directory, and let's call it kind of demo action JSON. And to start it, I just grab here our template we have on our documentation. So I can just fill it with that. And I don't need all of the fields, I just want to have one single integer field, my ID. And I need to be sure that the name is matching down here. And now I can just commit these changes. The dialog here will help me to create a new pull request out of that. And we just create that. And after the creation on the pull request, several checks will start now. That's the normal workflow we have here on GitHub. You see there are a lot of checks. They are just running now in the background. And so that we don't have to wait, I have prepared here another pull request. It's basically the same. We just created a new schema. And now, when all the checks have passed or finished, I can see here a few of comments. Like the first comment asking me about the proof, because as David already mentioned, we cannot really delete something from Snowplow again. We can only hide schemas, but not delete. So we wanted to have an additional gate when there is really a new schema introduced by a developer. He just needs to kind of approve it by checking here the list, the check mark. And then that's a really cool feature we have integrated. We can just make another comment on the same pull request down here. And when I just write this comment, it will trigger another workflow run in the background, which will then publish this schema to Snowplow dev environment. This is really handy. So when the schema is deployed, I'm already able to make an end-to-end test with my entire schema implementation. And the second comment, which is down here, it's something similar. We have another command in place that is really crucial. It's the generate tracking types. Now, yeah, maybe a little bit bigger. This is the command we have in our system, which will generate all the TypeScript types and the helpers out of the schema definition. And it's crucial that those things are always in sync with all the schema definitions. And here I just created the new schema file itself, not the types. I totally forgot about this command. And this is also detected by the checks on our continuous integration. And now he just have run the command for me, and he generated all the TypeScript things out of it. So I can also see here, here's the type, also with the same field number in that case, which is still the integer. And it also created some hooks down here, which can be used to directly implement that in React. So yeah, I would have to wait a little bit more to execute those steps, but I have prepared another Stade. So it's again the same, but here I have run the autofix, and as you can see, when the job is done in the background by the workflow, it just reacts with the rocket emoji, so I know now it's done, now it's integrated, I'm ready to continue. Same with the snowplow publish. So in that moment I know that if I check it on the snowplow backend, I can see this new demo action is deployed to dev in that moment. So now I'm already ready to actually implement this event. So for that purpose, I just switch to my local dev environment in VS Code on the same branch. So we have the schema in place, we have the types and the helpers in place. And here I just want to make a short demo, like we have a small demo for a component dialog. And that's a cool thing. We can create isolated demos for single components in our development system. And here it's really just a small demo of this dialog. So I want now to implement this new event on a click event, or when the user clicks this open button. So this would be down here. We have the button with the click handler. And now it's really a breeze. Kind of, I can just get my track event by using this hook, which is called something like use track demo action event, exactly. And now I can just call this, and even Copilot already sees the type in there. So yeah, my ID 42, that's good. If I would do something wrong here, the type is failing, because of course there's no other field than my ID. And that's the thing that David also mentioned, like it's really type safe as far as we can go. And now if I would check that again, I can go here to my snowplow extension. And now when I click that, I can already see this new event is called or fired. Also with my field, my ID 42. If I would now push those changes to my branch, everything is in place. And I can really make an integration test end to end. The events are received in the dev environment. And then when I'm ready and I merge the whole pull request, everything is getting automatically deployed to prod. And that's it. That's basically the workflow we have now with schema as code. Thanks.
Good. Okay. So maybe to wrap things up, bad developer experience likely leads to bad data quality. And the shift left approach we used, so including front-end developers very much into the process, has fundamentally changed how we work with data. And finally, data quality is the currency of trust in analytics. Thank you. And also important to mention, we are hiring. We are looking for a lot of folks, even my replacement. So check out job descriptions. We have a lot of open positions, and yeah, you can work with this setup if you want to.
No sales.
Not sure. Do we have time for questions? Yeah. Okay. So So there's already always this guy. Yeah. No. Please.
Terrible presentation. No. Really cool. Reminds me of a lot of current ongoing problems. How do you define data trust or data quality? Or how do you measure data quality? Because you say it leads to bad data quality, but how do you measure it?
As I already mentioned,
KPI or a dashboard where you see our data quality score is 10 of 10?
I mean, for sure we know how many fail events we have. So fail events that are not according to schemas. That's a very low percentage, basically because of all the safeguards. But as I already mentioned, data quality is kind of a fuzzy term, because only accurate data doesn't mean it's actually meaningful or you're driving any business value with it. So I think there are many different perspectives on data quality. I mentioned these 7 pillars.
So you don't track like how often do we get data incidents reported by teams or by whatever?
We do, but we do not yet have like something like a KPI, time to detect or time to fix. That would be some way of measuring data quality, or at least getting rid of quality issues. But as I mentioned, I think it's not only something you can put into a KPI, because all these downstream things, all these usage, ease of consumption things are hard to actually build a KPI of. Okay, you can use like how many people are using our data beyond the product analyst team, some kind of stuff, but it's not, from my perspective, it's not so easy to build meaningful metrics for these kind of soft things, usage, lineage, and that kind of stuff. So
you might be able to guess what my question is going to be. You talked about including the front-end developers in this tracking orchestration process, and what I want to ask is about basically what is the net benefit compared to the approach where we say, okay, we instrument a kind of standardized SOP, whatever you want to call it, which many companies choose to do in order to not have deviance from teams where one team tracks like this, another team tracks like that. There's one standard operating procedure. You spend initially a couple of months setting it up, and then it's very low maintenance and very low overhead, and you handle everything downstream, data analytics with analysts who are doing modeling work anyway and answering questions anyway. Do you really think it's worth it to do this approach where downstream the consumption still requires modeling, it still requires thought from analysts, it still requires stakeholder questions to be taken apart and really asked what the problems are? Because it seems to me like you have more overhead this way.
Interesting and valid question, but I think the track everything trap is really a problem. So it's quickly that you basically just create a data graveyard. With a lot of events, you basically track anything. You have no idea how accurate the whole thing is, and you end up with a lot of events. Even for us, in terms of volume, you end up with a lot of events nobody's using. And I think that tendency that you track everything and in the end doesn't know what actually is meaningful and how should we actually use the data is a bigger danger than we might think. It very much depends on the organization. If you're just two guys or so, probably component-based tracking is the better approach. In our case, we thought about it, but even the components are so highly nested that it's actually impossible to do.
Because I mean, Remo was showing the example of a button, but I'm sure that button does 97 different things in your case, even though it looks like it's just a button, right?
Yeah, exactly.
That's, I think, what you're referring to.
Yeah, exactly. Yeah.
So, one question about the validation of the explicit values themselves, because you have shown that when you define the type, like you can define like a minimum and maximum value, for example, or something like that. But then, do you still do validation outside of the JavaScript type, like on the ingestion layer or on the aggregation layer?
Exactly. So we do have data quality. Just a type is just like a fundamental layer of data quality, and it doesn't help you with missed events. It doesn't help you with event peaks. It doesn't help with like completely missing information, that kind of stuff. So we do have assertions, we do have additional monitoring, at least for crucial stuff. And of course, we finally have still errors. We still have problems. That's obvious. We never have error-free tracking, but our application is also never error-free. So it's kind of a standard thing, so to say. It's just to invest that we can actually reuse that stuff and that we work on meaningful things and not fixing errors, right?
Sure. Thank you.
You're welcome. Great. Thank you.
Would you like to say something, or would you like to do? Okay. Do we have the HDMI cable somewhere? Yes, this one. Ah, this one. Okay. Let's go. Yeah, thanks for having me. David was very specific when we talked about the talk today, and he said just 5 words for me as briefing for that. He said, be brief, please be brief. So, I will talk about 20 minutes about the introduction to Malloy. And who has worked with Malloy or any semantic layer before? No one. Perfect. So why is this important? Oh, sorry, before we start. Well, maybe if you're interested, we issue a magazine. You can subscribe for free. I also have some editions over there. So feel free to do that. Here we go. Perfect. Why it is important to work with a semantic layer? Well, if you do an analysis of SQL manually, or you work with AI and MCP, well, you need to have a clear definition what you're looking for in the database, how your metrics are calculated, and so on. And from my experience, most companies, they start over and over again when they do analysis. They start from scratch. They, just go with creating a SQL query over and over again. And then while you have, let's say, deviations, maybe in the definition of a metric, because, once you calculate it slightly different than you did it before, and so on. And semantic layers basically are a solution to that, because what they do is they create an abstraction layer and metadata between the actual physical representation of the data and the analysis tools. And what we basically do here is we say, okay, we go with our analysis team, that we have clients, or we have Kunden in this case, and all the information about this clients are in a specific table. We have a single source of truth, which means, we do a definition, we create a definition, and when the definition is created, we use it over and over again. So we create reusable code. And we separate the logical view of the data from the actual storage, from physical storage of the data. So how to do this? Oh, sorry, I have one point here more. Data democratization, I don't like that buzzword at all. I think you're a big fan. Matthew, where are you? Matthew? Still here? Here, over there. I think you're a big fan of that, right? Sorry for that, but for me it's just a basket. I haven't seen a company yet where this actually works in a way. It's practical. However, that's the idea, right? To enable people to work with the data in the same way as professionals doing it. And as usual, that's my only slide here. So we do a live introduction. So be nice. So what you do, Malloy is a Visual Studio Code integration, and Visual Studio Code has, of course, in the Google Cloud Shell, it's available, which means, let me scroll in here a little bit. So what you basically can do is you can create, or you can go to the extensions here and check for the Malloy extension. Just need to install it, and then basically works in the Google Cloud Shell. You can just connect your BigQuery data, your DuckDB data, and so on. Malloy has a slightly different approach than IBIS and the Boric semantic layer. Has everyone worked with Boric semantic layer before? No, okay. So basically what you do in Malloy is, well, you describe the data and how it is calculated. Compared to the approach you use with Borg semantic layer, where you basically give a path to the data in the database. So first one you describe, the other one is basically a map to the data. So let's start with that. So first of all, we do a configuration. So I use the BigQuery data set, BigQuery obfuscated GA4, whatever data set, you know, the one where you basically can see how you shouldn't do in a GA4 implementation. Here we go. And we have two options for that. Well, we can go with the actual SQL query here, which is select from whatever, which is running the SQL query all the time. Or we can go with a dynamic table, which is the actual underlying table here. So what's the difference? Difference you see over here when it comes to table suffix. So if you work with GA4 data or sharded tables, you want to use table suffix, right? You don't want to have all the data and then sort it out later in the SQL file. So basically what you do is you go with a dynamic table here that, okay, my actual table is, here is my GA4 obfuscated data set. That's just a copy in my personal account here. And say, okay, every time I access this, I want to replace, or want to give it a table suffix here, which represents the asterisk. I mean, you're familiar with how it works with sharded tables, but this is the first thing you need to know. Well, you can do it, you can access the actual table and the physical data, or you can access the SQL query. So, which makes it easier. If you want a sharded table, use the real physical representation of the data. If you maybe have like a view, you can basically connect the view directly to it. Okay. So what we do now is here, we import these files here. Go with that. We import our GA4 events, and we call it GA4 events, and we import the actual connection. And then, well, we just give it an information how we want to handle data. So basically, we access the data, and while accessing the data, it is basically transformed. For example, if I go with the GA4 date, event date, which is an integer, for some reason, still didn't go, that's around for a few years, but still doesn't get it here. Well, I said, well, I don't want to work with an integer. I want to pass it to a date all the time. So I said, well, I have GA4 event date. If I access this one already, or all the time, well, go with the pass date function, which is represented by the exclamation mark here, which means, well, we're running a BigQuery function, and I export it. Also, well, I just can rename the dimensions. Go with okay, I'll have a date string here, which is my event date, or I have an event timestamp. GA4 username is my event name, and so, GA4 event name is my event name. And I can also create, for example, Booleans, or already integrate where clauses in it. For example, I can create a Boolean here, which is page view, that, okay, yeah, it's a page view if GA4 event name equals page view. So I already get true or false at a point in time I access this here. And also, well, I can define my measures. So for example, I think, oh, well, total event is count. That's fine, total event is count. If I create something like that, I said, well, unique users is count GA4 users user pseudo ID. David, what is basically saying in this?
I can just do some unique users and then I have the correct.
Yeah, but you know, well, means about a distinct. So if you add something in the count function, it already has a distinct in it. So you don't need to handle that, right? So if you go with count here total events, well, it's basically counted in the same way you would go with count. If you add a dimension to it, Malloy is already doing the distinct for you. Nice. Also, well, you can add where clauses to it. So say, okay, I want to create it, I want to just measure it when total events contain, or when the event name is total page view, right? So just go with that. So I don't need to, well, handle it in subqueries and so on. I just do these definitions here. One more thing I actually wanted to mention later, but I did now. Well, if you want to access event parameters, well, you know the event parameter thing in BigQuery, it's kind of unique, I would say, how they do it. You may see that's not in dimension here if I want to access the page location by, because, well, I have max, which is an aggregated function. So I use it as a measure. Doesn't make any difference. But I access it by maximum event parameters. I can directly access it here, and then it will be unnested automatically. That, okay, where my event parent key equals page location. I don't need to do an unnest. It will basically create a subquery. We'll see this in a sec, create a subquery, and unnest it there, and then join it back to my actual representation of the data. Okay. Well, we can just run this now. I have more, but we'll just go with that. We have now our source, which is J4. We have defined our dimensions and our measures. So we can run this easily by we import our job file here. And you see, well, I have all the information here available as dimensions or as measures. Still, page location is a measure for this point of view, but also all the information I have in my BigQuery database. And of course, I can use them now. So how I use it? Let me check what we do here now. So what I can do is, well, I said, well, I want to run a query here. So we go with GA4, and I said, okay, now I need to define how to extend the schema I've created, and what I actually want to do, right? So what I want to do is, well, first of all, I don't want to access all the data. I want to go with table suffix here, and said, okay, it has to be larger than 1st of January 2021. I want to group it by event date, and I want to aggregate unique users and page locations. Right, so I can run this. And also I can create the SQL query here. Let's create the SQL query first. Maybe the internet connection is not as good as expected. Let me see. Here we go. So basically, based on the schema I've defined, and based on what I want to do, because that's what the analyst basically can do very easily, created that SQL query. This is running against the database, and it's getting me back the results. So, well, if I change something in the source, of course, it will affect all the connected ones here. But also, you see, well, I get a table back. What I really like in Malloy, well, they just don't focus on tables. You know, I'm not very good with visualizations, but you can also create a bar chart for that by just adding bar chart as a comment here, and then you will create, hopefully get a bar chart. Perfect. Right? So you can basically add a bar chart here if you like to. You can do some visualizations. Also, what you can do is, well, we can go with we run session pages. Maybe you want to know what session pages is. Hopefully you want it. I created a view based on the definitions we have. I created a view and said, okay, well, I just have a view which contains pages per session. So I said, okay, we just filter it by our Boolean we created earlier directly out of the schema. Here is page view. Well, we group this by, we group this by user pseudo ID and event timestamp. Why did I use event timestamp here? Maybe I have a reason for that. I cannot remember. Sorry. I use page location, page title, and session ID again as a measure because, well, we need to access. We need to access via the max function, and also, well, the session ID, we need the event parameter for the value and the end value for GS session ID to concatenate the information to have a unique session ID, right? So we can basically run this, and what we do here is, well, since we are using the aggregate function, unique users need to be grouped by, for example, page title, and we do an aggregation based on the concatenation of the unique users in the session ID. Well, so if we run this, here we go. Well, we just need to say, well, I want to access the view. It's fine, and then this may take a couple of minutes here, and then I get, okay, that's the sessions I have, well, by page title, right? Because that's what I defined there. And of course, I can not only create bar charts, I can also create scatter charts and line charts and charts. Well, all the charts you want to create. Well, that's actually quite nice for visual representation. I really like tables, but sometimes, I mean, the scatter chart is sometimes really nice, right? You see. well, actually, maybe a line chart would be better. Not sure. No, actually, line chart doesn't make sense because it should be a representation. Yes. Okay. So for a moment, I thought you wouldn't get a joke, but however, bar chart would be great. Okay. Okay. And of course.
How the pizza will be sliced.
And of course, well, I can also do nested data directly in it, right? So, well, we have basically the same here. We run GA4 with, oh, well, tables are fixed. We group it by event date. We aggregate unique users. But then we'll do nesting within a line directly there. So we said, well, based on the event name, we want to group it by event name and total event. So what we do is, we said, well, there's a unique user. We group it by event date. So we want to have event date, unique users. But within each event date, we want to have a table which contains the event names and the event total events. Right, very easy. So we can run this here. Here we go. So you see here, well, very easy. I have event date, unique users, but a table within the sphere. So, and the beauty is, well, SQL get complex over time, right? So especially if you do things like that. But you see here, well, create a very clean SQL query for that. Well, couldn't get more complex over time and so on. But basically, well, it helps to make it easy. We don't need to create the SQL query, actually. Just go with, okay, no, I want to have a table within a table. Well, I go nesting and do nesting and a nesting if I like to. That's what it's about. And of course, I just can create a dashboard for this as well. Just want to share this. So I can basically create a dashboard here and maybe zooming is not optimal. But however, I think you got the idea. So, based on that, so far the introduction to Malloy. I think I'm in time, right? David? Yeah, okay. Here. Matthew was, however. No, sorry. Introduction to Malloy. Well, maybe you have seen similarities if you use Looker, not Looker Studio, but Looker. Basically, when Looker was acquired by Google back in 2018, something like that, well, the founders, not sure if they dropped out or something like that, but that's basically their new project here. So Malloy is in the, let's say, an early productive stage. There's still things going on, like, okay, well, you can add like custom definitions, which is very helpful if you use MCP servers with AI. So basically, you can describe the nature of your data. Let's say we have event date. Well, say, okay, event date is year, 4 digits, month, and so on. That's what's expected. There is no dash in between or something like that. Or maybe there's a dash in between. Well, this is something where Malloy is developing to. And I think they have also an MCP server, which is very good if you integrate it with Cloud. If you go with Gemini and so on, they don't support standard I/O, just HTTP for now, so you need to bridge it. But however, that will be a feature in the future. And yeah, thanks so far. And if there are questions, happy to take some.
Yeah. So one from my side, because we've been thinking about semantic layers for quite some time now, and I'm wondering, isn't it kind of a broken promise when you compare it to any kind of, let's say, old school by now SQL abstraction tools like DBT, data form, SQL mesh, something like that? Because what my feeling is really is that the syntax is really cool, and those notebooks feature in Malloy is really nice. But in the end, the metric, how you define the metric, still depends on how it's filtered and how it's aggregated. It will always be like that, right? Because revenue aggregated by users will be kind of different than revenue aggregated by traffic sources. Just by its nature. And the question is, because in that case, you would also have to have second definition based on your aggregation layer or filtering layer, right? One way or another. So where's the advantage of this approach over just having a data mart and then grabbing the cleaned up and pre-prepared data from the data mart table built in DBT with the right documentation, for example?
Okay, I don't go with the analyzed assumption here, to be honest. Well, if there are two different metrics, or no, sorry, if there's a metric which has two definitions, there's something wrong with the definitions and not with the code. So basically, it's about naming convention as usual. It's about, define your SQL query, have one definition per metric, but that's a business logic. So this isn't, from my point of view, that's nothing I need to handle in the semantic layer. From my point of view, that's something that needs to be handled by the business department. When if I get your question right.
Maybe I give you a wrong example. So let's say we have a metric of revenue coming from directly the e-commerce system. Right?
Yeah.
As sum of the revenue from the right?
Yeah.
But when we want to report that to a certain business unit, let's say, how the definition is still the same, right? But how, what's the metric going to be reported depends on how you aggregate it.
Yeah.
It will always be some of the revenue, but grouped by different dimensions, right?
Yeah.
And in that case, you still need to have different views with different aggregations operating on the same metric. You cannot. We now get a question. So basically, you're saying is, you want to have one view, and this view contains basically a metric, and it's going exactly in the same way all the time for all the reports. Exactly.
That's not how Malloy works. It's basically saying, okay, you have the underlying database. You have a definition of each of the aggregations. And you can have multiple aggregations. You can have multiple views, use multiple measures in it based on a different business definition, and totally fine to create this business definition. That's not part of the actual semantic layer process. That's something the business department needs to do, and that's where basically the beauty of a well-defined semantic layer is basically.
But in that case, where do you see the value of doing semantic layer this way rather than using data form, for example, or DBT? Because the underlying table still needs to be defined, right? Either the syntax is different.
Yeah. So the beauty is, or basically, what is the use case? First of all, you have maybe a department of analysts, they don't know SQL at all, or they don't have the experience to do that. So basically, you teach them to write the code exactly that way. The other example is you go within a large language model, and you describe by the definition here, you describe it easier to access specific measures and dimensions in a way you want to calculate them, and then Malloy is transforming the actual SQL and is delivering it to the large language model. So basically what you ensure by that is that there is less hallucinations and there's a higher data quality based on that. So that's it, that's the idea.
Okay, cool. Thanks.
Okay, thank you. David.
Maybe a very similar question. So is the intention of Malloy that there is not a pre-aggregation or pre-modeling of the data, let's say with DBT, data form and so on? So Malloy is actually consuming raw data, or is it not really an either-or change, so basically using both tools is fine? Because I assume even if you have DBT or so on, data form still, Malloy still creates value, right?
Yeah, I mean, why you're using data form with DBT is you have stages of your data flow, right? You create your data, then you have assertions, and you put it to the next stage, and if it doesn't fit the requirement, you push it back. Malloy can't do this, right? Because it doesn't push back data, it just delivers a SQL statement. There are no assertions and so on. So you go with DBT, and then have the data in a format you want to work with it. If this is the format you would work with it, and if you write a SQL query manually, that's not a question here, but you can consume it. But it's not replacing DBT or data form, since there are no stages. It's just accessing the data by creating, from my point of view, a very clean SQL query. So that's it. That's basically the very clear use case. And as far as I understand the roadmap of Malloy, they don't try to go in that direction. What they're trying to do is just to enrich data by, well, by custom definitions and so on. They add within the schema, so they don't need to be in the table, but well in the schema. That's the direction they want to go. They don't want to replace DBT or data form. I can't totally different thing from my point of view.
Cool, thank you. More questions?
Okay, if you have more questions, David, I think let's break. Thank you very much.
Good to go? Okay. All right. Hi, everyone. Also really nice to be here from my side. I'm a product manager at Galaxus, but just a year ago, I worked together with David. I was in the product analytics team for a while. And in this team, I had the chance to work on our A/B testing framework together with two colleagues of mine who did the lion's share of the work of what I'm going to present today. So kudos to them. I think it's a really, really cool solution that we have that automates a lot of the process of A/B testing at Galaxus. And what I want to talk about today is these 5 topics. So I first want to start with kind of why we did this, so where we started, and what challenges we had scaling A/B testing in the company. And then I want to show you exactly what the framework consists of, so how the architecture is set up of this A/B test tooling, and also what changed after we implemented the system, and how we think we can improve it next. So maybe as a quick example, this is our product page on Galaxus. And under the hood, what's happening is that there's actually multiple experiments usually running. So for example, we might think about, oh, in the search, should we put the product type that you're currently on? Or should we maybe sort navigation differently? It's currently sorted alphabetically, but what if we sorted it by click-through rate? Or changed the algorithm for the recommendations, or surfaced different marketplace offers that we have, There's a legal notification that we have to make about shipping fees. Where do we place it? It has to be somewhere near the price, but there's some leeway for us. And we also don't only test kind of, I'll say, user-facing improvements, but also performance topics. So for example, how do we store images and how fast are they delivered to the product page? So why is A/B testing so important for Galaxus? So basically, before we release a feature, it usually has done several rounds of testing internally. So that might be things like employee testing, or we work a lot with simulations in search, for example, or it might be things like using LLMs as a judge or AI agents as a judge. And the last step in this chain of testing is A/B testing. And you might argue that that's actually the most important step, because this is really the gold standard for causal inference, and it allows us to see whether a feature benefits users or whether it actually harms users. And I would say that A/B tests kind of help us in two ways. The one side is quickly making small wins or identifying small wins. So this is kind of the classic example of, should we make this button blue instead of green? The A/B testing framework really helps us speed up on that front. The other side are these more larger decisions where we want to be quite confident that this is actually positively impacting users. And again, on that front, A/B tests help us because they give us confidence in the causal impact of a feature. So there were several challenges that we had at Galaxus a couple of years ago. One was that we had a quite high test volume, and that with the smaller central analytics team that we had, it was quite difficult to cover all of those tests. If you look at our shop right now, I checked before, I think there's like about 11 A/B tests that are running right now, and all of these A/B tests need to be evaluated at some point. And testing volume just increased so quickly with new feature teams coming in that we couldn't really cover all of the tests that were coming our way. Another related point is that evaluating A/B tests was always quite manually intensive. So all of the steps from data modeling, data cleaning, making charts, running statistical models, all of this was done by the data analyst manually. And the last point is that evaluation also was quite different per analyst. So each analyst chose slightly different statistical methods. They chose slightly different charts. One did a pie chart, the other did a bar chart. And this didn't really give product teams a whole lot of confidence in the decisions that we're making. So this is why we decided to build an A/B testing framework that kind of allowed us to automate this whole process. And we decided to build our own in-house solution. This is kind of the philosophy that Galaxus has with very many of its decisions. We try to build it ourselves before we buy it. And the A/B testing tool that we built was kind of structured around the belief that many experiments are quite repetitive, both in terms of the data that you use, and this kind of connects to the talk from before about a KPI layer. Frequently you reuse KPIs, like conversion rate in our case, but also in terms of method. So for each A/B test, it's probably beneficial to identify outliers, remove outliers, do statistical corrections, for example, if you're testing very, very many segments or very many variants. And we tried to build a tooling that kind of accounted for this repetition, and that did standardization across these steps, and that automated very repetitive tasks. And if we go back maybe to this mental model again, I think this side here, small decisions, is where the A/B testing framework really helps us the most, because it just makes us much, much faster at making these small decisions, and it frees up a lot of time for analysts to work on the bigger decisions that are more important and that maybe take a bit more thought and nuance. So here you see our A/B testing framework in detail. It basically consists of 5 steps that goes all the way from implementation to, at the end, evaluation and documentation of the test. And a majority of these steps runs completely automated for us, so we can go through each one in detail. So maybe talking about implementation first, this ties to what David and Remo were talking about before. We have a front-end component that allows us, for each session that comes into our shop, to randomize them into different variants. So let's say we want to run an A/B test on should we display empty star ratings on the list or not. I have one example here. This is actually an A/B test that's running right now. So there's 2 variants. In one variant we're not showing empty stars, and in this variant we are showing empty stars, no one has rated this product yet. So this is maybe like a small change if you think about it. But this is the implementation part, right? So the devs can leverage this component. And then in Snowplow, we track for each experiment that's running which session comes in, which variant they were assigned to, and then some like metadata about the experiment. So for example, which team owns it. That's the first part, the implementation. And this is still manual, right? So this is done by the engineers. Then the second step is the data collection pipeline. So we collect all of this tracking data in Snowplow. And after the A/B test is live, there's a kind of pipeline that starts that's fully automated and that joins all of the data from the different sources. So we have experiment metadata, from when until when is an experiment running. We have session metadata, which variant was a session in, which device did they come on. We have behavioral data, so what did they do in the shop? Did they convert? Did they click on something? Did they exit early? And then we have the standard KPI definitions from our KPI layer. So let's say this is an experiment that's quite close to checkout, then we will usually have e-commerce conversion rate as a standardized KPI that we add. This data collection part happens in Dataform and BigQuery, and the output of it is basically a table that contains all of the information that you need to analyze this experiment. And this table is then fed into the monitoring dashboard, which I will show you afterwards. Here, maybe just a quick example. For the experiment that I was talking about before, you basically have a table that contains which KPIs we're going to measure for this experiment, brief description. It also has a link to a Confluence page where the experiment will be documented. So all of this data gets saved in our data warehouse. Then the third step is monitoring. So this is while the A/B test is running. It's also fully automated. The data that we collected basically flows into a Tableau dashboard. And this Tableau dashboard does two things. On the one side, it performs bug checks. So for example, if you have a sample ratio mismatch, let's say in one variant, we were expecting 50-50, but we're seeing something more like 40-60, which can mean that the experiment was implemented faulty. This is something that you would see in this dashboard, but then you can also monitor the KPIs of an A/B test. How is average order value developing? How is conversion rate developing, et cetera. And the dashboard doesn't only work for single experiments, but it also has an overview for all of the experiments that are running in our shop at a given moment. So you kind of get an overview of what's going on right now. Then the next step, after the A/B test has finished, after the runtime is over, we go to Python, to a Jupyter notebook, where we have built basically a library of different functions that allow you to analyze an experiment. This includes functions for data cleaning, for example, so detecting outliers. It includes functions for statistical analysis, so like hypothesis tests, t-tests, bootstrapping, for example. And it saves the results that come out of this evaluation script back to BigQuery. So you don't only have all of the behavioral data in our data warehouse, but then also the results of the experiment for historization. And again, this step is also fully automated. Basically, what you need to do as an analyst is in the Jupyter notebook, you put some parameters at the beginning, and then you just hit run, and everything runs through, and the data gets saved. And then we get to the last step, which is manual again, which is documentation in Confluence. And I think this is kind of where the value or the magic happens, I guess. You kind of interpret the numbers, the raw numbers. Let's say e-commerce conversion rate went up by 3%, but add to cart rate went down by 2%. What exactly is going on here? This is what you would discuss then with product owners, with UX research, for example, or also with the devs. And by automating, so this is an example of such a Confluence page, by automating these 3 steps here, analysts can focus much more of their time on the last step, which I think is quite valuable. So maybe what did we observe after we implemented this framework? So I think one huge benefit, of course, concerns throughput. So we estimate that we are twice as fast now to run an A/B test as before, where everything was done manually from A to Z, and everyone did it again and again and slightly differently. Which also means that we can run much, much more A/B tests. So currently, yeah, we're at over 100 A/B tests per year. I think the second benefits that we saw were related to kind of the quality of the analysis. So we have much better statistical scrutiny now. All of our experiments kind of fulfill the same threshold in terms of statistical soundness that we require. And also, I think what's nice for non-technical stakeholders is that the presentation is slightly more consistent. So the Jupyter Notebook doesn't only do evaluation, but it also outputs visualizations, for example. And they're always in the same format, so each PO can kind of learn it once, and then you can understand outputs by any data analyst, basically. And this, I already said before, I think it really frees up much more focus for things that are less repetitive, for like longer term analyses that answer maybe bigger questions that are more complex. Maybe a word on how we want to improve the framework. I think there's several things that we can still make better. So from a technical point of view, I think one thing that I would find really cool is to move to more adaptive A/B testing, so things like sequential testing or multi-armed bandits, so that we can kind of speed up the time to decision, because right now what we do is we say, oh, we expect 2% uplift on add to cart rate, we're going to let the experiment run for exactly 3.5 weeks, and then we have to wait. But there would be ways to speed this up. So this is something that I think would be cool to implement. Another thing is we currently do session-based A/B testing. So whenever you come on your phone or your desktop, you will have a different version of the shop. And what would be cool is to do more analyses on a user level, because in the end that's what matters, right? And to also check not only what are the effects within a session, but what are potential effects on your long-term behavior as a user. Do you come to the shop more frequently? Do you delay purchases more, for example? So these are things that we would be able to measure with this. And also on the insights front, I think there's a couple of things that we could do. So one thing that I would find quite interesting is actually integrating an LLM. So that part of this documentation step that I was mentioning before, that we just dump data into an LLM, kind of like notebook LM style, and see what it comes up with. I think sometimes it can be quite helpful as a kind of creative prompt to think about things in a slightly different way. Another thing would be like meta-analyses. I mean, we have so many A/B tests. We have more than 100 a year. Over the course of several years, it's very, very many A/B tests. And conducting studies across these A/B tests, what were common themes, could be quite interesting. And the last thing, which we always struggle with a little bit, is institutional memory. So with so many A/B tests that are running, how do we make sure that people know about what's happening and what the learnings were, and how do we make sure that not only within a feature team's learnings are shared, but across the broader organization? We've tried several formats, like newsletters, for example, but we're still trying to find, I think, the optimal setup for this. So yeah, this may be as an outlook of what I think we can still improve. That's it from my side for a short overview of experimentation. If there's any questions, very happy to take it. Yes?
Just out of curiosity, thanks a lot. This was really sharp. Maybe stupid question, naive question. When somebody comes to your website, is it possible that the person gets assigned to multiple experiments, or do you like just assign them to one and leave everything else without?
No, so you do get assigned to multiple experiments. So the way that we try to set up experiments is that this hook or this A/B test only triggers once a user actually gets into contact with a certain feature. So let's say we're A/B testing a new search relevance ranking. This should only be triggered once someone actually inputs a search keyword and triggers a search. But at each point where you interact with something that's being tested in an experiment, you're randomized into a variant. So you're in multiple variants constantly.
Thank you.
Yes?
Maybe somewhat,
I think we can hear you. Right? Yeah.
maybe somewhat controversial question, but does actually more experiments really lead to better outcomes for the organization? Because while it lowers the barrier to making experiments, people start formulating experiments for should the button be green kind of things, when maybe most experimentation practices over time have shown that people should actually they should take risks. They should want to run bigger and more risky experiments, which would actually reduce the overall number of experiments, which is somewhat the opposite of your approach. So have you seen holistically, really over the course of the last several years, by increasing the number of experiments, do you really believe that it's worth it?
I think that's a very valid question. I recently read an article in, I think, Harvard Business Review that said you're probably A/B testing too much, and I kind of agree with that. I think there's definitely the risk that, yeah, you start running small little A/B tests that won't really change the needle on big things. I think what we try to do, at least in my product team, is to focus these like smaller A/B tests on things that are really, really easy. So like, I don't know, for example, we had a button and we changed the wording. It was super easy, but it actually led to like a 5% increased click rate. So I think being conscious about like, yeah, which small things do you want to push, but like which bigger things are you working on as well, I think is quite important. We haven't ever done an analysis of like how we improved as an online shop in relation to the number of A/B tests that we've done. That could be an interesting metric, but we have never looked into it. But yeah, I generally agree with your sentiment, yeah. Yeah.
Maybe a question about the length of your A/B test. You said that you're aiming to make it shorter, but maybe for some new features, do you also think of the novelty effect, for example? Because it could be that a lot of people are curious about it in the beginning and click a lot and do a lot, and then maybe after time it just changes.
Yeah, so it very much depends on the feature and how much traffic it gets, like how long an A/B test runs. So there's A/B tests that run for several weeks. I've seen A/B tests that run for like 6, 7, 8 weeks. The minimum that we try to do is a week, just so that we can kind of also cover a business cycle, because the behavior of users on a Sunday is very, very different from those on like a Tuesday, for example. And we also try to include longer term, let's say, interaction rates, for example, with a new feature to measure these things like novelty effects. Yeah.
So, one question here, but first of all, thank you very much. Great presentation, and I would really love if you could share it as well. That would be great. And the question is, how do you work with the product owners and product managers to create the test hypotheses that make sense, right? Because from my experience, sometimes they really need a lot of guidance.
Yeah.
So how do you approach that?
So I agree. I think for us as an organization, I will say like the data maturity per product owner varies quite starkly, I would say. And I think the relationship that a data analyst has to their product manager is also always a little bit different per team. But I really think I think that's one really, really important job for data analysts, to kind of educate their product managers on what makes sense as an hypothesis, what makes sense to measure. So for example, I've seen experiments where they're like, oh, we're going to introduce a new button and we would like to measure click-through rate. I mean, of course it's going to be clicked. There's a new button there that wasn't there before. So I think, yeah, being honest with your product managers and kind of being that sparring partner is quite important.
And do you have like a product analyst in every product team?
Yeah, so this is the setup that we currently have is a central analytics team. So one data analyst usually works with 2 or 3 feature teams. We try to set it up so that these feature teams are related. So for example, the data analyst that works for the product page also does the checkout, which is like the immediate next step. So there might be some similarities between these products. But right now the data analysts are not in the feature team, which we were discussing before, has, I think, upsides and downsides. So I think one downside is that you're much more distant from the team, and maybe you don't feel that strong sense of ownership for developing a product from a data perspective, and maybe you're not so close to the devs and to the product manager. I think an advantage, though, is, for example, that you might have a bit more of a holistic view, so you don't only analyze KPIs for the product page, but maybe also, hey, if we change something on the product page, how does this affect KPIs in the search? Like, do people suddenly get distracted from searching again? What does this mean for customer journeys through the shop? Things like this.
Great, thank you.
Cool, thanks.
right? We have the first collection layer that we can also test with a great tools like Analytics Debugger. Shout out to Analytics Debugger. Yeah. Then we can obviously do some schema level validation, both when you have a very great relationship with the developers, you can ask them to handle that. If you don't, then you can use some other tools like what we're going to talk about. And then you can also do data quality tests during the aggregation itself, like with DBT data form assurances whatsoever, right? So what I wanted to show you is kind of like a similar approach to what David and Remo have presented for Digitec, but what if you don't have that highly engineering focused organization, which in my experience there are not that many of them. So huge props for you guys to actually be in that place. I'm really jealous of you. And so basically what we developed is like basically it's a cloud function that validates any incoming event so that you can integrate it with server-side GTM, with Tedium, with Adobe, with whatever, against the JSON schema that you actually input. And that allows you to do the validation on the fly in the real time against both the predefined values or, for now, regular expressions. So that's it from the very high level perspective. And now we can look at it in more details. So we have a repo on GitHub that's live. As you can see, the last merge is 7 hours ago. so quite a fresh topic. And basically what we're doing is that we have we have two main services. One for the backend that manages this cloud function, the bucket with the JSON schemas, everything like that. And we're also using API gateway here. Thanks. We're also using API gateway here on Google Cloud to validate that somebody should really access your endpoint. And then we write the results of the tests into a BigQuery table. And then on the other side, we basically have a small app built-in Streamlit that you can deploy and manage the schema yourself without having to write code. So somebody that's not technical can really do that. But the next stage would be to actually put it in a proper Git repo as well. So that feature is coming very soon. And I want to walk you quickly through the project itself. So, as I said, it can support any JSON schema. It logs everything in BigQuery. It's quite nice with the cloud functions. Work quite quickly. API gateway fully automated, so you can deploy it basically in 3 minutes. I will show you how. And then you can connect it to your server-side GTM with just one tag. But whenever you do that, please use link, because you probably don't want to copy your entire loads that you're sending to your GA4 setup, for example, right? Because it would be waste of effort. So if we take a look at the actual repo here, let me find my VS Code. That's it. Those are the schema files here. So basically, it comes with preloaded set of all the major GA4 events, like GA4 standard events, and then it has a schema file for all the events in the GA4 schema. in the div events. Let me make it a bit smaller. So that's basically like that, right? We need to have an array of items, then items have nested events in it, and so on and so on. And over here, you can also write your assertions. So for example, if you only want to have item ID that's a string and not like an integer, that's something that you can add here, or when you want to have the like some kind of particular patterns that you can define with regular expressions, it's also totally possible. And then let me see if I have it now open. No. And then if you want to deploy everything, we're using Terraform here. So how many of you have used Terraform before? Great, cool. So basically, Terraform is a way to standardize your cloud infrastructure deployment in a pre-configured files that you just write down your configuration in. And then basically all the resources that you define are deployed automatically. You can also do version control and in a nice way that way. And it's a really cool way to manage your cloud infrastructure. So in our case, everything that we have to do is that we need to fill in the data for our Google Cloud project, basically. So that's for the front-end setup. You just need to define what's your product ID, what's the region of your Google Cloud project, where does your data lay, and then some basic configuration for IAP. And for the backend setup, I think it's even simpler because it's just a setup of your BigQuery schema and your Google Cloud storage buckets, where the JSON objects would be loaded to. So so basically right now we need to deploy the API gateway setup, a cloud storage bucket, a BigQuery table, and a cloud function. Right? So it would take quite some time if you wanted to do it manually using Cloud Console. But now, if we use Terraform, can you see it? Yeah, kind of. I can also. I cannot make it bigger. So, if we run Terraform plan, this will show us what has changed with the setup between the current state and the previous one. At this case, not much, because I have already deployed it before. But we can see that six resources have changed basically in comparison with the previous deployment. So everything that I need to do is to run Terraform apply, and in this live demo it will actually break because I don't have everything set up in the way I should have. But basically that's everything that you need to do. So the entire deployment of the whole infrastructure is taking like 3 minutes, because we are waiting like 1.5 minutes for the API gateway to be actually propagated before we can use it in other resources. So that's everything you need to do in order to deploy that. And once you do that, you can just go in BigQuery. Once you have, of course, connected everything in your GTM setup, you can go into BigQuery, and I will actually show you the live data of one of our clients. So please don't take any pictures now. that's already running it, because I think it's the best illustration for that. So there's the schema of the table. We check out what's the event, what fields the error was in, what kind of type of error is it, what was the expected value, what the actual value, what the timestamp, basically everything that we need in order to do the validation. And then the data looks like that, right? So we can see that in this incoming event, the text displayed field, which should be a type, which should be a non-empty string, was actually an empty string, right? And then we can, of course, attach all the metadata here we want, like if we want to have like page views, user agents, like page URLs, user agents, referrers, anything, like we can, of course, just do that and run the validation. In here, we actually have like a full event data just for debugging purposes that we're storing here as well. So that makes it very easy to analyze the data. And once you have it in this kind of table, you can just either connect it to Looker Studio. We'll have a template that you can use in order to just visualize that. You can run any kind of anomaly detection, etc. We will be coming up with the built-in feature for that quite soon, I guess. And then you can also see some of the results. Like for now, it's not a lot, but some of the results inside the actual Streamlit UI. So if you decide to use the UI, you can use it also for this purpose. So let me quickly show it to you. So I'm going to go into Streamlit. You want to run Streamlit. And that's basically the UI we have built if you don't want to use Git or like raw JSON files or so. So basically it shows you all the schemas you've got in the bucket. You can visualize that, you can edit it. So if you want to add an expected value for the field of primary category, then you can change it and then you can upload it directly into your cloud storage bucket, etc. So that's quite nice. We also have, it's not working in the demo, but it also has like a whole repository of parameters. So you can also see in what events is each of the parameters being used. You can also categorize them to have like e-commerce parameters, user parameters, etc. based on that way. And you will also see the option to show the data here. At the moment, we connected to a project which probably doesn't have any data, so you will not see anything here. But the advantage of using Streamlit is it's very easy to build in data visualization and repos directly in the app as well. Oh, actually do have something. So basically, that's the error rate by different events. As you can see, most of the page view events have the error, and our error rate in terms of incoming data is like 100%. Here you go. So that's basically what we have. If you want to deploy it, everything again you have to do is to have like a GCP project, a proper service account that can be used by Terraform, and then just need to do this pre-configuration of the Terraform files. I would really encourage you to do that because it's like super quick, and you know, and like we spent some time on the documentation here. It is open source with the GPL 3.0 license. So if you want to commercialize it, if you want to fork it, if you want to do anything with it, please go ahead. Another thing is that it comes with quite an okay defined HSMD file. So if you want to like add extra features with LLMs like Cloud Code, Gemini CLI, anything like that, it's like really quick and really nice. And we also have a small roadmap which you can contribute to, but you of course don't have to. That if you go into issues now, those are some of the ideas we have for the future variations of that. So that, for example, yeah, we can have this anomaly detection query that runs on top of the existing BigQuery data. We can do the version control for schema files, which would probably mean like moving them away from this project into a separate repo that you can just have like a custom CI/CD rules with GitHub Actions, also built with an automated way. I would really love to have an LLM-based documentation parser that can, you know, have all the spreadsheets or all the PDF files or Confluence pages or whatever, and just build the schema files in an automated way, etc. So yeah, that's pretty much the plan for it. The link to the repo is diffused/events validator. So if you want to play with it, check it out, or so, please be my guest. And if you guys have any suggestions as for what features you would like to have added or so, I would be also really open for any of them. Right now, the development of the micro product like that is like really quick. Like adding a feature with Cloud Codes takes like 5 minutes, right? So we can iterate very quickly and have like a very nice community tool that hopefully a lot of people can benefit from if they don't have this nice engineering department as Galaxus. so that's pretty much it. Thank you very much. And if you guys have any questions, then please come up. Thank you. Cool.
Okay, thank you.
Thank you. Thank you.